Hello and happy Thursday, everyone. If you missed our 10 hacks to help improve your FlowJo analysis last week, I just wanted to give you some highlights of what we talked about so you can see some tips that we recommend when you're using the FlowJo software for analysis. And the first tip I want to talk about is keywords. Now, keywords are embedded in your file. The FCS file has a header file and the list mode file, which has all the data in it. In the header file is a lot of information that you can use to do quality control and troubleshooting and things of that nature. But a lot of everyone puts keywords in at the instrument, even though you can do that when you're running the machine. Now, if you want to see what keywords are in your file, if you go and select your file and do a right mouse click, you will get this menu to be able to look at the inspect. Of course, I'm on an Apple, so you can see Apple sign I will get you the inspect as well. And that inspect will open up a window that shows you the keywords. And this lets you see things like what the voltages were set at, what the distribution of the dynamic range of the PMTs were. This lets you get information about was quality control run, who ran the instrument, and things that are given automatically as part of the FCS file format. This also lets you allow where you can see any custom keywords. Now, if you didn't add keywords at the beginning of your experiment, one thing you can do is you can add those keywords in FlowJo, and there's a reason you want to do this, because it really helps you sort your data, organize your data. You can use how you've got the keywords to help do your batch analysis and tables, etc. So to do that, you just have to select on the Add Keyword button here, and you're going to open up a window. And here you can see I've added a keyword called concentration. When I click that button there, I'm going to get a concentration value column down here in the tube windows, which I can then fill in whatever values I want. Now, one of the nice things about using keywords is, like I said, you can sort your data. So just for fun to demonstrate this, I took that concentration window and sorted the concentration in two different ways, either low to high or high to low. I then did a concatenation on the file that let me take all the, in this case, titration values and put them into one file, and I added in that the keyword concentration, so that became a feature that I could actually use as well. And so here you can see in this figure, here I've got a typical histogram plot. I've sorted from high to low, so you can see how the concentration, as it decreases, or signal decreases. Now in this other plot here on this, you can see now I sorted from low to high, so you can see that as well. And you can see the increase in the staining on this plot. Now, being able to separate those, plots using the keywords and use that for concatenation is a great little tool. Now, another way to think about it is complex keywording. So a lot of people will bury details of the experiment in the name of the file. So they might name, and in this case I'll show you, we named the type of stimulation, how long the stimulation was run, and we had two different stimulations and we had two different time points. So what we're able to do is, using that add keyword, add three keywords. As you can see here, this is the file. This is the file name, and I've highlighted the three columns, and we're able to add those three columns. And then over here you can see on this side we have the column for stimulation, which condition, the time of stimulation, and then the sample number. Now all this is now embedded in my FlowJo file. It does not get embedded in the original data, but it is in my FlowJo file, so when these are pulled up, I will have those. And I can use those to sort my data in a wide variety of ways. If I wanted to look at just a certain stimulation condition, if I wanted to look at a certain time point, that can be very, very useful. The second thing we wanted to talk about, we highlighted, was the whole compensation. That FlowJo has a compensation wizard, and when you bring in data into the FlowJo package, it will automatically look for files that it thinks are compensation and put them in a compensation sample, and then you can do automatic compensation. Now it runs an automatic compensation algorithm, and here I have some beads looking at that compensation window. Here we have a forward scatter, side scatter plot showing the plot where the beads were identified. And then in the middle plot we can see here the histogram showing the positive and the negative sample. And on the far right we have another plot showing the forward scatter, side scatter, the gating for the beads. In this experiment, we had positive and negative in the same tube, so it was the software used the same data for both cases. Now, the forward scatter, side scatter algorithm usually works pretty well, but sometimes it can mess up. And so here, for an example, is a case when it messed up. Again, on our unstained, we still have a nice population, forward scatter, side scatter. But here, over here, on our positive signal, the data gated down here in the lower left-hand quadrant, or corner of the forward scatter, side scatter. So there's a lot of debris in this file, and that became what dominated the data. So therefore, when we look at our histogram plot to identify our positive and negatives, you can see that the green negative peak is actually lower than the unstained peak. So that's clearly a problem that you would want to identify. Another thing that using these, using the wizard as you're inspecting it, is it likes to use a universal negative. It likes to look for a single tube that is unstained. And here's an example of that case where we have the unstained, single stained, and we have a universal negative shown here, and we have our positive beads shown on the far right. Again, forward scatter, side scatter. And in the middle here, we have the histogram showing the unstained universal negative in blue and the stained in green. And so you can see a positive signal here. I've highlighted in this red box the blue that represents the negative, but you can also notice that the green is there too, and that is coming from our positive sample, and you can see there's a difference in the autofluorescence. Now, recalling back to the second rule of compensation, that the background fluorescences of the carrier for the positive and negative carrier have to be matched, that would be a violation of compensation. So you'd really want to go back and adjust and make sure you're only using the positive and negative from the one tube and not using that universal negative. Now, I happen to like to do my analysis without using the wizard, so I tend to gate myself. And so here I'm just showing you on this plot, I've gated a bivariate plot or biaxial plot, so I can clearly see my negatives and positives. You can see in this case, I see some super bright signals shown in red here, so I would want to exclude those super bright, because there's generally it can be caused by a wide variety of problems. Since these are beads, it's more than likely the beads are sticking together, and so we don't want to add that into our data set. So that would be lost in a histogram, but we see that in a biaxial bivariate plot. One other thing that you can do in the compensation wizard, in the compensation package in FlowJo, is calculate the spectral spillover matrix. I'm sorry, the spillover spreading matrix, the SSM. And this is a really useful tool that you can use for two good reasons. One, you can use it for quality control. You can calculate this SSM and compare it over time on the instrument that you're using to see if you see differences. The other way you can use this is to help you understand what instrument you would want to do and how you might want to design your panel. So if you have data from colleagues or other people using this, you can calculate that SSM, and you can just use beads for this, and you get a matrix similar to here. So what I'm showing on this figure here are two different instruments, and we've calculated the SSM for these two instruments, and we've highlighted here. We have the fluorochromes and going across on the y-axis, and coming down in the columns, are the detectors. So we can see where fluorochromes may cause problems. They're highlighted in red and yellow. And now if we look at these two machines which have similar layouts, you can start to see that there's some differences between these instruments that may impact where we might want to design a panel or might want to look at. If I'm running this instrument and I see this is happening, this is an indication that there may be a problem with the machine. This machine here is much cleaner, and you can see there's a lot better areas to design a panel using that instrument. And you may also want to then investigate what other differences there might be. Are there laser differences? Are there other options that might be causing that difference? One thing that's happened in flow cytometry, turning to our fourth point now, is that there's a lot of programs for analysis being written in the R scripting language. And if you're not a huge fan of using R, or haven't used R, or not used to that interface, it's not easy to get access to those. So you have to rely on others or find another way. FlowJo has created a what they call the Flo-Jo Portal, and a way for you to bring R scripts into FlowJo. And it's a really useful tool. And one of the things you have to do when you're bringing it to set these scripts up is you have to go over here into the preferences window, and if you can see here under the I'm sorry, I always get this confused, the actual name, the diagnostic window, I'm not sure why it was put there, the diagnostic window, there's an option which I've highlighted here with this red arrow to point to two factors. One, where the R program is on your computer, and two, where the jar files are on your computer. Now, you need to download the R program, which is free, and put it on your computer, and then you just need to make sure you put the right path in. Now, on the PC, it's pretty straightforward. On the Mac, the best thing to do is you need to open a terminal and type in the command type in the command which R, and that's going to give you the path to get to R, and you can just copy that and paste it. Now, to get all the other packages, FlowJo, under the FlowJo plugins menu, you can go here to the FlowJo Exchange, and you can see that here. This is a website, and this is just showing you a capture of that. You can either download all the files or download a specific plugin that you might want to use. These include things like Tisney, Spade, FlowSoms, there's a cell ontology, FlowClean, and my new favorite program, Flow AI. I will tell you, when you're going to start installing R scripts, you want to make sure that you read the instructions and you follow the appropriate commands, which again, they give you those commands that you're going to enter into the R window, and it will run those commands, so now you can use those. So my favorite is now is Flow AI, and that tool lets you automatically cleans up your data, looking for differences that may be caused because of microclogging or other discontinuities in the run, and it will generate a good and a bad gate, so that you can then go ahead using that gate. We've talked about using time as a parameter and the flow stability gating. This is a way to automate that. And again, like with everything in FlowJo, you can bring it up to the group level and apply it to all your samples. Last thing I wanted to talk about, or some highlight today, are some of the things that you can do with tables that you may not be doing now. So first off, if you've ever done a table in FlowJo and you've dragged everything over, you know that you get these really long names in the window when you export the file. However, if you go in when you have set up the file and you label, there's a right down here at the very end, it says name. You can label each of those points that you're going to be exporting with a shorter name that's easy to remember, and when you export it, it's going to now show just those shorter names. So here I was doing a staining index, so I was exporting medium fluorescence intensities in RCBs, and I just relabeled them, and now they're right here in the file. That makes it much easier. One of the other reasons you might want to do that is in FlowJo, in addition to adding keywords and adding the data, you can actually add formulas. And again, if you click on over here in this window where you're adding a new column, you click over to the third one, which says formulas. You can now enter a formula using the FlowJo tool that will call back to the files, and you now have a new column that's going to be a calculated file. And in this case, I was telling you we did a staining index, and here's the results of that. Here we have our concentration, which is one of the keywords that we put at the beginning. We've now also calculated the staining index, which is shown here. And one of the nice things that you can quickly do is there's another option where you can select the parameters and you can actually graph this. Here is what the graph looks like. This is actually trying to do a best fit line, but you can at least see the graph. So if you missed out on the webinar, we'll bring it around again in the future. Hope these couple of tips and highlight what you can do in FlowJo, and there's lots of other great tools in FlowJo that can help you in your analysis. So with that, I'll thank you, and I'll see you next week.